4.5 is Systems of Inequalities. Before we graph systems of inequalities, which is more than one inequality at the same time, we're going to practice graphing one linear inequality without checking a point just because it's faster. Okay, the first step is you're going to graph the boundary line. Remember, it's a dashed line. If it's less than or greater than, it's solid if it has the equals at the bottom. If it's greater than or equal, we shade the side of the line with the higher y values. Less than or less than or equal means shade the side of the line with the lower y values. Okay, let's practice on this first one. Okay, first thing I'm going to check. There's no equals sign here, so it's going to be a dashed line. So let's go ahead and do the boundary line. The y-intercept is 2, down 3 over 4. And you can do it more than once if you want to try to make it straighter. Okay, and then this says y is less than. Less than means lower, so I'm going to shade below the line. If you can tell which of these sides is below, you just shade below. If not, find a point, go down. That's the side you want to shade. Okay, next one. Okay, the symbol in the middle has an equals. The little line is equals. If it equals the line, it's solid. Y-intercept's 5, 1, 2, 3, 4. Slope is half. If you want to do it extra, you can do it extra. Solid. Okay, the inequality is less than or equal to. Less than is lower, so I'm going to shade below the line. The y value is below the line. Okay, try the next two. Unpause when you're ready to check. Okay, for number 3, it was a solid line because the equals sign. So I started at the y-intercept before, went down 1 over 3. Since it's greater than, I shade above the line, which is up here. This one is dashed. The y-intercept is -3. The slope is -2. So when I graphed it, I went down 2 over 1. And I'm going to shade above the line. If you can tell which of these sides is above, you go straight above. If not, I like to start at the y-intercept. And I go up, which means I need to shade up on this side. Okay, next two are similar, but the lines are a little trickier. Okay, it's going to be solid because of the equal sign. Okay, the y-intercept is not listed, it just has an x, so this is like an imaginary 0. So I'm going to start at the 0. It's x, so it's like a 1x. So I'm going to go up 1 over 1. And it's solid, so I'm going to make it solid. The symbol's less than, so I'm going to go below the line, which means I'm going to shade down. Start at the line, go down. Okay, one more before we do this system. This is dashed. It says y is greater than 3. The y-intercept is 3. The slope is not listed, so this is slope of 0. So I go up 0 over 1, or if you know that's a horizontal line, you can draw it horizontally. It's greater than, so it's above the line. So it's all the y values that are greater than 3. Okay, a system of linear inequalities is a set of 2 or more linear inequalities using the same variable. So this is an example of a system. There's 2 inequalities. Inequality has less than or greater than symbol. They both have y's and x's. A solution of a system of 2 inequalities is an ordered pair that is a solution to each of the inequalities in the system. Okay, let's look at the first one. It says y is greater than -x minus 2, and it's already graphed for me. I can see this is the line right here. Y is less than -5x plus 2 is this other line. It doesn't matter if I know which one's which. It says pick a point in the solution region. That's the shaded region. You can pick any point in the solution region. 0, 0 is technically in the shaded region, so you could pick 0, 0. You could do -1, 2. You could do -2 up 3. Anything in the shaded region would work. Because 0, 0 is available, I'm going to use 0, 0 because it's, as always, easier to plug in. Okay, I'm going to check it in both inequalities to verify that 0, 0 does in fact work. Okay, I'm going to copy the first one, just so you know which one I'm copying. Okay, if I plug in x is 0 and y is 0, I get 0 is greater than 0 minus 2. 0 greater than -2? Yes, it is. Okay, now let me check it in the other line inequality. Okay, 0, 0. So 0 is less than negative 5 times 0 plus 2. 0 is less than 2, yes. So if you pick a point in the shaded region, it has to satisfy both inequalities. And this would have been true even if I had picked negative 3, 2, negative 4.5, 4.8. Any point in the shaded region should satisfy both. Okay, let's try number 2. This one is also already graphed for me. It says pick a point in the solution shaded region. I can pick any point up here. I cannot pick 0, 0 because it's not shaded, but I can pick anything else. So I like to pick numbers that are not too bad. So maybe if you like 0, you could do 0, 4. Maybe I'll do 1, 4. Okay, let me try 1, 4. It's in the shaded region. Okay, and then I'm going to check it in both equations. It should check for both. Let me try the first one. I'm only copying it so you know which one I'm plugging in. Okay, so be careful. The y is not the 1, it's the 4. So 4 is greater than 4 times x minus 3. 4 times 1 is 4 minus 3. 4 minus 3 is 1. 4 is greater than 1? Yes, it is. Okay, let's check the second inequality. Okay, y is not 1, it's 4. So 4, negative 2 times x plus 3. 4, negative 2 times 1 is negative 2 plus 3. 4 is greater or equal to 1? Yes, it is. So it checked for both. If you pick any point in the shaded region, it has to work for both. If it fails for either one, it is not actually a solution to the system. Okay, now let's actually graph the whole thing together. Okay, to graph a system of linear inequalities, we graph each inequality on the same coordinate plane. We're going to check for dashed solid lines and we're going to shade it appropriately just like we did before. Okay, but then we have to graph the other one as well. After that, you have to find the intersection of the shaded regions or the double shaded region. That region is the solution, is where all the solutions are. The main point of the graph is to get the boundary lines in this double shaded region. There's a couple ways people do it. I'll show you both. Okay, let's just graph first. For example 1, y is less than or equal to negative 2/3 x plus 3. It's equal, so it's solid. The y-intercept is 3, slope down 2/3. Is it solid? Solid. Okay, now I do want to know which way it's shaded, but I kind of don't want to, I need to find the double shaded, so I'm going to not color it all the way. Okay, it's less than, so it's going to be below the line. So maybe you could lightly shade it. Less than. It's because I'm trying to find the overlapping region. I don't want to get my whole picture crazy. Okay, the second inequality is y is greater than 3/2 x minus 1. This is dashed because there's no equals. Y-intercept is negative 1. I go up 3/2, and it should be dashed. Okay, now I need to find the shaded region. The shaded region has only to do with this purple line now. Okay, this is greater than, so I'm going to shade above this line. I'm going to use a different color. Okay, if you have trouble telling which way, if this is the line, above is up, so I'm going to shade up here. Okay, now I'm going to do a light little shade here, and I'm going to stare at it. Okay, you can see that these two lines have split this into 1, 2, 3, 4 areas. I'm looking for the area where it was shaded twice. That's actually the solution region. This has no shading. This is only green. This is only orange. This is the area with the green and orange. So that area is my solution region. And that's the part I actually care about, and that's my shaded region. So make sure that it's clear that that is actually the shaded region. Okay, you can darken it, or some people like to kind of do arrows and things like this. Okay, the shaded region contains all the solutions. So all the solutions are over in this area. So if they ask me to check a point, I can pick any point over here, and it should work in both. That's also a good way to check your answer on a test or a quiz. Okay, now that you've seen it, let's try one more, and then you'll do the practice problems. Okay, this is y is less than x plus 1, dashed. Y-intercept's 1, slope is 1x, up 1/1, dashed. Okay, and then I'm going to do a light shading, or at least look at it and kind of consider the way it's going to go so you can keep track. Less than is below. So I want to be below this line, but I don't want to shade too dark because then I can't see the other area. Okay, now let me graph the other one and then I'll look for the overlapping region. Y is less than or equal, solid, to negative 1/2 x plus 3. The y-intercept's 3. Down 1 over 2, solid. Okay, this one is below. Okay, and then make sure when you're checking, you start from this line. And I want to go below this line. So I'm going to do a light shade. Below, 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 below. Okay, and then again, we're looking for the area that satisfies both inequalities, so it needs to be shaded twice. There's 1, 2, 3, 4 regions. This is only blue, empty, green. This is the part that got shaded twice. So this is the only area of the graph that satisfies both inequalities. So make sure you darken that region so it's clear that that is the solution region. Okay, and if you're asked to pick a solution, you can pick any point from the solution region. Okay, go ahead and try the practice problems on the next page. Be really careful. I'll put up the answers at the end of the period.